Do you have an 80 square foot camper van and want to turn the lights on and off from any position in the camper van without ever having to move? Well, you're going to need a lot of switches. 2, 3, 4, 5, 6, even 10-way switches. And that's exactly what we're going to cover today in lesson number 3 of this branch circuit playlist. My name is Nate, and welcome to the explorist.life Mobile, Marine, and Off-Grid Electrical Academy. Now, before we get started, there's a couple prerequisite pieces of information you need to know, like cutting wire, stripping wire, crimping terminals into wire, but we've already covered that in a specific playlist of this academy, so go back and review that if you don't already know how to do this part. And lastly, before we get started, the fuse block that we're using in this particular demo is the Blue Sea blade fuse block. Now, there's several different types of fuse blocks on the market, like the Progressive Dynamics fuse block, the Blue Sea Safety Hub, the Tiger Expedition UFO 200, and all of those are realistically going to be connected in much the same way. They're all getting their power from a different distribution hub, like the Victron Lynx distributor, which is getting its power from the battery. But we're going to skip all of that side of the system and focus mainly on how we get power to the rest of the branch circuit. Let's get started. I do think I'm going to regret making this video because it's honestly entirely too complicated to wire 2, 3, 4, 5, and 6-way switches, but I've sort of done this video in the past and everybody had questions about how to do it, so I'm just going to show you how to do it and then let you decide if you actually want to do it. I did try to sort of make it with wire here on the table. It just became cumbersome, and so I've put it onto a bit of a presentation so we can sort of see the inner workings of the switches necessary to do this. So I'm going to step back here, get all reset, and get going. We're going to start with 3-way switches, which is switching from 2 different locations. I know that's already sort of confusing, but it is what it is. The switch that you need to accomplish that is a single pole double throw on switch, which means that inside of the switch there's just basically, a lever or a slide that just goes from one side to the next side, and it allows that power to go through and connect to either of the output pins. So there's 3 pins on the back of the switch. One is input and the other 2 are output, depending on which way you want the power to go. So illustrating this, it would sort of look like this if you had 2 different lights. So up for one light, down for the next light. Pretty straightforward, I do think. But to do switching from 2 different locations, you actually need 2 of these lights, or I'm sorry, 2 of those switches. And here's how that looks. You'd have 2 of the same switches, the single pole double throw on switch, and you're just going to be basically following the flow of power through the switches. You're sort of sending that flow of power through a bit of a maze. And given the power gets to the other end, the light's going to turn on. If the power does not get to the other end, the light's not going to turn on. So in this example, power is going this way, connecting to this pole, which is technically the out, but we're treating it as an in, and then sending it out through the in to the 12-volt light. And down this way, it's coming this way, this way, this way, but when this switch is in this position, this toggle is up here, and it's not able to get power, so the light turns off. So to sort of illustrate this even further, here's the various positions of which the light turns on and off. We will put this in the blog post if you need to see this slowed down a lot, because it's really hard to sort of comprehend. Good luck. Okay, so moving on. So to do a 4-way switch where you're switching from 3 different locations, you need to introduce another switch type into the mix. And it's a double pole, double throw on switch, which is sort of kind of 2 of the previous switches just squished into one switch. And this is how the internal mechanism is looking. There's 6 pins on the back as opposed to 3 pins for the previous switch. And as the switch goes on and off, this internal mechanism connects these 2 and connects these 2, and it's separate on either side. What we need for 4-way switching, though, is a way to make that switch reverse polarity. And so it's basically switching its inputs and its outputs. And this is how this looks. So you connect your inputs to the middle 2, and then you would jumper your bottom 2 to opposite ends on the outputs on the top, right there. And so the flow of power is going to go this way, in here, up here, around this way. Nope, that's wrong. Really hard to follow. This way, here, here, down to here, and then out. So you got blue to blue. It's on opposite sides, and same thing for this reddish color here to power. So it's going to swap depending on if the switch is up or down. You know, if it's going this way, that's why I just described. If it's going this way, the polarity flips. Notice the red's on top here, blue's on bottom, blue on top, red on bottom. Illustrated, here's how it looks. So you can see that as the switch is flipping up and down, it's connecting these two different terminals, and it's flip-flopping the output polarity. So that's where we are so far, and this is what you need to introduce into the previous circuit to allow for more switches. And here's how this flow of power sort of works, whether the light is on or off. So you can see our single pole double throw on switch right here and right here, and we've just introduced that polarity reversing switch into the middle. So power is going to flow in this way, across, polarity's flipped this way. But if this switch is toggled this direction and power is up here, there's no way it's going to get power, so the light's going to be off. You know, if you flip this switch on here, power is going to redirect this direction, this direction, this direction, this direction, and since everything matches up, the light's going to be on. So to sort of illustrate this, here's how this looks, you know, depending on which of these switches are on versus off. You know, you can see you're toggling any combination of the switches, and the light is just turning on and off, regardless of the positioning of the others. If you wanted to add another switch, basically you can just throw this switch, you can just throw as many of these switches at the problem as you want to, and it's still going to work. So flow of power this way, up here, you can sort of follow, lights on, or if you toggle this one off, it goes to the off position here, and then power still flowing, but power is only getting to this last switch, and then this last switch is basically stopping that flow of power. So if you illustrate this, here's how it's looking, depending on which of these switches you're flipping. Like I said, we'll put this on the blog post so that you can sort of see all of this flow of power. And you can just keep adding these switches so that if you're sitting in your 80 square foot camper van, you don't ever have to move to turn off your lights. Or alternatively, if you don't want to do this, which I honestly don't recommend doing this because this is really, really complicated, I would get something like the Red Arc TVMS that we'll talk about in a future video, to where you can control your lights from your phone, a switch, or the touch screen on the wall. So if you need that kind of flexibility in your system, it's a way simpler concept to sort of accomplish with basically a module that's going to do it for you. So is that it? I think that's it. Okay, so basically this is why this is not a good idea. Please do it if you want to like educate yourself on it, but test it on a tabletop first to play around with it, get it all tested and everything like that. But it's really complicated as far as like actual installation. I do feel like this is going to cause problems if you actually try to install something like this into a camper van. So, but you've now been educated on the whole process. So in the next video, we're going to be dialing it back a lot. It's going to be a lot simpler than this. And we are actually going to move on to a different device, water pumps with a switch, and we'll see you over there.
Even like in a house, like a two-way switch is fine. Like you can walk across the room and turn off the light.
Yeah, because like in a house, even nowadays, you've got like the Lutron, what is it? They've got like the programmable switches. And so like even on a 120 volt circuit, like there's solutions out there so you don't have to do this, because you can do this on a 120 volt circuit. But you know, like with the, it's the Casa? I don't know. It's like a programmable switch that like connects to your Wi-Fi. It's like sort of like Ring or whatever. So all the smart home stuff. So yeah, you don't need to do this. This is silly.